Welcome back to Ox Tools. I'm Tom. So what we got here is kind of something special. A few months ago, I had asked for some volunteers or victims, depending on how you think about it, to volunteer a micrometer for me to practice lapping the faces real parallel. So I wanted to do this, and I had checked my micrometers, and they were all in pretty good shape and not in need of lapping. So I kind of put the word out to the internet, and I was overwhelmed with the responses. So all the folks that responded, I really appreciate it, and I appreciate you volunteering your micrometers for potential damage. But one came through that was a particular interest, and I think it's really aligned with the kind of stuff that this channel's about. And it's connected with this sticker here, this Blue Origin sticker. And what we have here is we have a 0 to 1 inch micrometer that was donated, or well, not donated, loaned for potential victimization by Daniel Roche. And he works for Blue Origin, and that's Jeff Bezos' company. And so there's kind of a special story behind this micrometer that's of kind of nerdy interest. So I guess back in 2015 they were getting ready to launch one of their test vehicles, and there's a link to that particular launch in the description and at the end of the video. And they asked all the engineers prior to the launch. They said, "Hey, listen, we got to put some payload in the quote unquote crew capsule. So if you have something that you want to send up into space, send it down to Texas, and we'll load it in the crew capsule, and up it'll go. You might not get it back, but up it'll go." So Daniel had this micrometer that he got at an antique store on a bike ride. So he put this micrometer up in space, and so this thing's actually flown on the video, or on the PM4 vehicle that you see on the video in the link, and been up to low Earth orbit, I guess is the correct term. Now, which is pretty cool. So yeah, now you understand why I picked this particular micrometer. And the faces are not in awesome shape, so this is a great victim to practice on here. So Daniel, thank you very much for sending that up. And you know, even though the aerodynamic designer for the Blue Origin vehicle probably worked at a adult toy store before before they came to Blue Origin, we'll forgive you guys for that. So anyway, we're gonna lap this micrometer. I already did a little repairing to the spindle to make it behave nicely. So if everything goes right on this launch, we're gonna get a good micrometer out of this process. So let's check it out and see how we're gonna do that. So Daniel, thanks again very much for loaning the micrometer. Okay, so here's the challenge here is lapping these two faces parallel to one another, and that's one of the requirements of a micrometer is no matter where you turn it, those two faces are flat and parallel to one another. So now normally what you do is you use a lap. Ooh, boy, that's blowing out the exposure. Let's cover that up. So I had made this lap, I don't know, a while back, and it's cast iron, and it's been lapped very parallel between this face and this face. And the idea here is what you do is you put a little bit of diamond abrasive on one side, and then you put it between the anvils of the micrometer, and one side guides the other side. So because this is parallel and we're operating on two faces that are basically parallel, we end up improving the one face, and then we reverse and do and rinse and repeat. So now there's problems with that a little bit. Let me set that aside. There's problems. So if the anvil is really worn, you know, when you're coming on and off of round stock, you tend to wear these things convex, right? So what we want to do is we want to establish perpendicularity with the spindle first, okay? And to do that, we need another kind of a lap here. And I also made this one, and this one has basically kind of a press fit with the bore, or a gauge fit with the bore, and a ring that we're going to ride on to lap the spindle perpendicular, or the face perpendicular with the spindle. Let me correction there. So what we care about is this face, but we want to be perpendicular to this spindle very closely, and that's what this lap's about. So this is made by boring very carefully and facing all in one setup, very, very light cuts at the end, and then doing a final lap to take off any burrs. So these are very perpendicular to one another. I don't have a number, but it should be very, very close. So that's what we're going to do. We'll take this apart. We're going to lap this spindle first, get that nice, and then what we'll do is we'll use this other little lap here, okay, to lap the fixed anvil parallel with that, and then we're going to check it with optical flats. Okay, and then here's a couple of other examples of parallel face lapping here. Now these are Pratt & Whitney style chair edge finders, and they have two faces that have to be parallel to one another, and they also have to be central over this face very accurately. So this is a fixture for checking parallelism and also distance from the reference face, which is this face here. So the way these work is you plop them over the edge of a part, and then you run an indicator around in a circle around the spindle, and it touches both sides as you rotate, and then you centralize over that, which in turn is this reference edge that you've put this on. Now this is a different type here. This is a Moore type chair edge finder, and it also has two parallel faces. But this one's a little easier to make because you can grind it basically right to dimension. So if you're going to make one, I'd probably make this style here, although this is, I think, kind of a cooler looking style, right? This one is a little easier to make. It's a two-piece, and you can get in there and grind that with the periphery of the wheel and the periphery of the wheel. This, you have to do some side wheeling, which is actually really tricky to get a very straight side if you're not super careful. So you end up lapping, and that was done with a sliding parallel lap here to lap those faces real close. Okay, so that's just for reference. Let's get on with our micrometer and get Daniel's micrometer squared away so he can show off to all his coworkers. All right, so we're going to okay. I guess that's just some quartz in the granite there. We're going to use our aluminum foil lapping technique here, and this is aluminum foil tape. I'm going to very carefully try to peel the backing off here without buckling the aluminum foil. And what this does is this gives us a soft substrate to embed the diamond in. Okay. And we got our nice clean surface plate, so we're just going to stick that down right in the middle of the world there, and then rub it in real nice. I got a gauge pin here. I'm just going to kind of go over it, flatten it out. Okay, so what that's doing is mimicking the surface plate flatness, and then we have a relief under here, right? So what we're going to do is charge this with a little bit of diamond here, okay? And we're going to use a 12 micron diamond to start with. The face isn't too bad, so we'll start with that. And if it's got some scratches that still show themselves, then we might go to a coarser grade in it for a little bit more. And then, this is a dry run here. Basically, I'm going to, so the surface plate guides the lap, and then I'm just going to move back and forth and do a little bit of this action here, and then we're just going to observe what's going on. So I want a landing place for that. That's nice. Okay, so let's add a little a little abrasive here. Okay. And I said this before, you really don't need a lot, okay? This goes a long ways. And then what I'm going to do is, this is just a little lubrication here, and this is just Kingsford charcoal lighter fluid, okay? And that's kind of all we need there. So let's do that, and then we're going to push this down into contact with the. I'm going to put a little pressure on this. I don't want to drag the abrasive too far astray off of the aluminum. All right, let's give it a quick look. Yeah, so you see the dark stuff? That's means you're doing something there. See what we got here. Oh, yeah, that's going to work great. You can already see that it's. I think that anvil is actually fairly flat, so let's keep going here. This is pretty boring video, so I apologize. Not much to see. Oops, okay, so as I was walking off of the edge there a little bit. Clean that off. Yeah. So hopefully the camera's picking that up there. I'll wiggle it around to see if the light catches it. Alright, so I'm going to do a little bit of that, a few cycles of that, and then we'll come back and we'll take a look at it. So I've added just a little weight. That way I'm not influencing the spindle in the fixture. I can concentrate on just keeping this nice and flat. So, let's see what that looks like. There was a pretty good little pit in the end of that thing that had to come out, so it took a little while to work that out of there. And I didn't change grids, I just started with it and continued with the 12 micron here. So let's check that under the with an optical flat and see how we're doing. A little tiny surface like that is a little tricky to do, but we'll see what we got. It's a lot better if you clamp the optical flat between the two anvils of the micrometer. So what we'll do is we'll do a rough check, and then we'll put the micrometer together and do a secondary check. So let's see what we got here. Okay, this is real hard to see here. Okay, hopefully you can see those. So we're actually looking pretty good just with this rough check, but the lines are real close together because this optical flat doesn't weigh very much, so the wedge of air is fairly thick. But I'm trying not to bump anything here between the flat and the anvil. So I think what we're going to do, we're going to install that in the micrometer and then do another check and see what it looks like. So let's check that out. So I'm pretty happy with that right now, and let's move to the next stage. All right, so now we're gonna put the optical flat in and kind of checked it, and I don't know, I wasn't real enthused with the repeatability. So I think this anvil is influencing the freshly lapped one. It's like, at least that's my story. I'm sticking to it. So I'm putting a little abrasive on the cast iron lap here. Okay, same stuff, 12 micron. And I'm only going to put it on one side, which is the quote-unquote A side. And then what we're going to do is we're going to put it in here and get it on the abrasive and get a little on the anvil, and then we're going to use the micrometer itself as our lapping fixture. To work this other side. Actually, I should, like a dumbbell, I have to turn this stupid thing around so you guys can see what the heck's going on here. This is probably better for me too. So what you want to do is make sure you got it well seated like you would when you're taking a good measurement. There we go. Keep the It's not like you're taking a lot off, right? It looks like I'm getting some swarf there. It actually feels better too. Feels smoother. Although it feels like it needs a little liquid love there. Oh yeah. All right, we're gonna take it out here in a second, look at it. All right, getting scared, I wanna look at it. All right. Let's see if we can get a prelim here. Oh, yeah, it's looking better than, I should have shown you guys before and after actually. Let's let me open this up. Get in there and clean it. Yeah. Yeah, okay, well, that's doing the deed there. Okay, I think we got a little more to do there. So I'm gonna do a couple cycles of that and then I'll come back and then we'll do a little inspection and see what it looks like. These are optical parallels here, and so what that means is, opposed to being an optical flat, which is typically perfectly flat or very, very close to flat on one surface, these are flat on two surfaces and they're also parallel. And these have a special use for inspecting the micrometer anvils. So after we've done a little bit of lapping there on the anvils, we can actually use these very carefully. And I cleaned these a little while ago. And what we do is we clamp down on the parallel under kind of normal measuring force with the ratchet. Then we take a look at it under the monochromatic light here. So these are looking pretty good. I want to play around a little bit more and see how much better I can get it. So, but let me try to get a shot so you guys can hopefully see the fringes in on the space micrometer. So let me reset the shot and see if I can get you to see that. This is kind of a hard shot to do here, so let's see what I can do here. Okay, there you go. So you can see it there on the spindle. You can see some fringes there, right? All right, now I'm going to flip it over. So I got to bring it into, see if we can, it's hard to, I got no reference point for the focus here. Let's see. Hopefully you caught it in there somewhere. I can see them from here, but my eyes can oh, there we go. Some of this stuff's hard to photograph, guys. Okay. Anyway, so they're, bottom line is they're looking pretty good. And I didn't mention it, but you see there's a thickness there's a thickness right here on the optical parallel, and this set includes 4, and they're different thicknesses, so you measure at different spindle rotations. So let's say they're perfectly parallel in one orientation. Actually, that's probably a good way to see if it's in focus here, Mr. Wizard. There we go. So that you can get quarter rotations of the spindle and check it in a bunch of different orientations. So, and I'm going to show you a different way with little balls too that you can kind of check the parallelism with on your own. Okay, so let's check that out. Here's the optical parallels. These were sent to me, my buddy down in LA from PTC Instruments, John Marcus, sent me this set. He had bought it or got it with a lot of tools, and he said, well, I'll never use it. And so anyway, he sent it along. It's actually really nice. Thanks, John. So 1/2 inch, 5.5125, 5187, and 5062. So that gives us, allows us to check the spindle at different points on the rotation. So let's do a little more lapping, and then we'll check it again. And then at some point, I'm gonna have to get off the horse here and send this sucker back. This is 4 micron diamond that we're using here. I'm just gonna put, that's like kind of a huge amount there. That's too much. Let me pull some off there. That's probably all I need right there. Yeah, there's a danger of getting too much on there. And then this is just Kingsford charcoal lighter fluid, in a dropper. In fact, I got too much of that on there too. So some of this is controlling the, I don't want it to run. All right, that's probably good. So I want it a little runnier than it comes out of the tube, but not too runny. Does that make sense? Does to me. We're going to do a little more on the anvil. Get some on there. So I'm just going to do it under normal measuring force here. So I'm going to try just pulling as opposed to pushing. It's the old, it's hard to, hard to push a rope, right? The one problem is that the disc can hit the frame here. You got to be a little bit scoot over, down, up, down, down, up. Makes it. All right. Oh yeah, we got some swarf on there, so we did something. So what we'll do is clean that real good. We don't want to transfer any of this to the measuring gear, right? Our nice optical parallels. Let me clean that real good, and then we'll check it again. So the other test that we can do that, and I've never tried this, okay, so I'm going to try it, is you take 3 different balls. They give you a different position on the thimble, and since these are very round and very accurately made, the idea is that you can detect any variations in the parallelism of the 2 anvil, or the 2 surfaces of the micrometer. Now, I don't know, like I said, I've never tried this, and I'm just told you just fish it around. I'm going to try really light pressure here, and then trying to notice if there's any areas that feel different. It feels different when it's not in there, when I drive it off the edge. Let's try high pressure or normal. So keep in mind that this is we're squashing this ball pretty good right now. Yeah. I'm just looking there. I mean, as far as I can tell, it feels pretty uniform. So I lapped this a little more off camera, and it's pretty good. I guess I'm almost to the point where I'm gonna stop. Let's try the next size up here. So this should be a different spot. The ratchet on this particular micrometer, probably from re-entry, is a little stiffer than than I'm used to. So yeah, I don't know. I really can't. I'm not feeling anything different really. So okay, let's try the last one here. The big guy. I think that's 1/4 inch. I'm not positive though. Yeah, 1/4 inch. All right. Yeah, I don't feel it. All right, and that concludes our test with the balls. All right. All right, let's take a look at this under the optical flats. Let me clean that spudge off of there, and then we'll look under an optical flats, and then conclude this video. All right, let's see. I'll try to get a close-up of those faces. They look pretty good, but looks are not everything. So we're gonna go through and check them on all these and see. Okay, I'll buy that for $1. So interpreting these patterns is a little bit weird. And Mitutoyo has a little sheet here that they kind of try to explain it, but they do a less than optimal job. Let's just put it that way. Then I'll explain why they ask for the pattern that they ask for, which doesn't really make any sense to me. So I'm mumbling to myself if you guys didn't notice. All right, well, let me reset the camera, and I'll try to get a shot here of one of these or whatever, so you can see the fringe pattern on both sides. All right, let's try this here. Find the happy spot there. All right, so you can see a couple. So what we want to see is multiple fringes And these are not super straight, but not too bad. But and then we want to see like one on, according to the Mitutoyo instructions, on this side. But I got like two. I got two there, or 2.5 or whatever. So, like I said, I'm not quite clear on these, their little diagram here, why that, and it doesn't really say what orientation that is either in relation to the micrometer frame, because the harder we crank on that, it spreads the micrometer open, so you can, I don't know, functionally kind of dial in whatever you want. Let's see if I can get a shot of these nice, freshly zim-zammered Anvils there. Okay. All right, so we're going to pack this little monkey up and send it back, and maybe it'll go in space again. Anyway, thanks for watching.